Let's begin with a question. If I ask you to count all the fingers on your hands, you'll get a number, 10. That's finite. Now imagine I ask you to count all the stars in the universe. That's not possible. That's infinite. In set theory, we use the same ideas. A finite set has a definite number of elements, you can count them. An infinite set goes on forever, you cannot finish counting it. Let's look at some examples of finite sets. Set A equals braces 1, 2, 3, 4, 5. This set has 5 elements. Set B equals braces A, B, C, D has 4 elements. The set of students in your class, countable and limited. If you can count all the elements and complete the count, the set is finite. We represent the number of elements in a set using the notation n of A. So in this case, n of A equals 5. Now let's talk about infinite sets. These are sets that have no end. Example, the set of natural numbers written as braces 1, 2, 3, 4, 5, and so on. We use 3 dots, called an ellipsis, to show that the list continues forever. Other examples of infinite sets include odd numbers, even numbers, prime numbers, real numbers. You can never list all of them because there's always another element. Let's go through a few more examples. Suppose we want to define a set of all odd natural numbers. We write D equals braces x such that x equals to n minus 1, where n belongs to natural numbers. This gives us the set 1, 3, 5, 7, and so on. Now, consider the set of perfect squares C equals braces x such that x equals n squared, where n belongs to natural numbers. This defines numbers like 1, 4, 9, 16, and 25, all square numbers. The rule tells you how the elements are formed. You can represent infinite sets in roster form, but only partially. You show the first few elements and then add an ellipsis to suggest that the set continues. Examples, the set of odd numbers 1, 3, 5, 7, and so on. The set of even numbers 2, 4, 6, 8, and so on. But not all infinite sets can be described this way. For example, the set of all real numbers between 0 and 1, we can't list them, and they don't follow a simple pattern. Knowing whether a set is finite or infinite is very important in mathematics. For finite sets, we use counting methods and direct operations. For infinite sets, we use rules, patterns, and sometimes approximation. This distinction is especially helpful in algebra, calculus, and probability, where different techniques are needed. Now that you understand the difference, you're ready for the next big idea, equal sets, where we compare not the size but the content of sets.